Hello, this is the third video in a series about complex numbers and their arithmetic and solving equations with them. The first video looked at just the arithmetic. Second video was looking at solving quadratic equations. And this third video is looking at solving equations where the answers to the questions, the x values, end up as imaginary numbers or complex numbers. So we have the job to solve for x here, and if you ever recognize that all the terms share a common factor, then you should factor out first. Not only do they share a common coefficient factor, they also share a variable factor. So we will factor out to start, and what we're going to factor out is a 4 and an x. Every term is a multiple of 4x. 12x cubed would be 3x squared times 4x. Negative 8x squared would be negative 2x times 4x. And then 4x is going to be just a 1 times 4x. And this is equal to 0. Now, normally when a constant comes out, you kind of like ignore the constant, but when a variable comes out, you can't ignore it. So what we're going to do is so we're going to say that either 4x is equal to 0 or the quadratic is equal to 0. And so dividing by 4 gives us the fact that x is equal to 0 as one of our answers. Look at the equation, plug a 0 in. For sure, that's going to be a true statement. And now we go to solve the quadratic. And so we're going to solve it using a quadratic formula. What we're going to have is the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. For us, in this quadratic, the a is a 3, the b is a negative 2, and the c is a 1. I like to figure out what b squared minus 4ac is ahead of time. Let me know what type of solution you have, whether it's imaginary, whether it's a repeated root, or whether it's two real roots. And so for us, we'll have b squared, that's a negative 2 who gets squared, that's a 4. Now be careful, it's minus a 4 times a 3 times a 1, all positive there, so that's going to be take away 12. And so we'll have a negative 8 underneath the square root. And so that gives us then an imaginary number. The square root of negative 8, as we saw in the first video, what we do with that is we write it as 8 times negative 1, and we break it into 2. The square root of negative 1 is defined to be I, and the square root of 8 is going to be 2 root 2. You find a perfect square that goes into it. You take the square root of each. That perfect square comes out. It doesn't, there's no number underneath the root anymore. And then we have 2 root 2 is what 8 is. The square root of 8. Okay, so back to the question now. We're going to solve the quadratic equation. This I like to think about it as like side work. It makes the write-up look nicer. Where we have the opposite of b. Remember now, if it's negative, the opposite of that is positive. And now the whole b squared minus 4ac has been simplified and solved for us. We note that we can replace it by 2 root 2i. The whole thing is then divided by 2 times a. A was equal to 3. And so we have 2 plus or minus 2 root 2i all over 6. Lastly, we break it into two pieces, 2 over 6 plus or minus 2 root 2 over 6i, and then we can cancel. They share a 2 in common. Final answer, 1 over 3 plus or minus root 2 over 3i. Okay, and 0. So the answers to the question are x equals 0 and these two imaginary roots. Okay, great. Geometrically, what's going on is that we're finding the roots. Anytime a function is equal to 0, we're trying to find where it crosses the x-axis. What we're finding out with imaginary roots is that when you graph the function, they don't show up. We're looking at real numbers, and so a cubic generally has this kind of a shape to it if the coefficient in front of the cubic term is a positive number. And what we're seeing is that it only crosses at 0. So the graph of this function crosses at 0, still does that turn, but doesn't dip down enough to go back through 0. Okay, great. And one last question here. It is a quadratic equation, but there's imaginary numbers everywhere. But it turns out that it's just some complex number arithmetic to end up with the quadratic equation, and we can solve it using the quadratic formula or completing the square. When you take 2i and multiply it by negative I, what you get is negative 2i squared. Now remember, I is defined to be the square root of negative 1. Squaring both sides, you'll see that I squared is negative 1. So we replace the I squared with a negative 1. Everything is multiplied though, and so that's just a fancy way of saying 2. 2 plus I times 2 minus I, that's a number and its conjugate. Where you have the same right and left side, but you have a different sign in between. When you multiply that, the imaginary numbers go away. When you FOIL it, we get a 4, a minus 2i, a plus 2i, and a negative I squared. The minus 2i and the plus 2i cancel. We'll have 4 minus I squared. Remember, I squared is a negative 1, and that's 4 minus that negative 1. Or 5. Fancy way of saying 5. And then finally, same kind of action, 1 plus I times 1 minus I, giving us a number times its complex conjugate. So we shouldn't have any imaginary. And then please don't forget the minus that's on the outside. Handle that last. FOIL, 1 minus I plus I minus I squared. The minus I and the plus I cancel. The minus I squared is a positive 1. And then we add the 1 to it from here. That's just a fancy way of saying 2. All of that has a negative on the outside. And so our result then is a negative 2. That's a fancy way of saying negative 2. So it just looks scary, but it's not that bad. You end up with a quadratic. It is 2x squared plus 5x, and that's equal to a negative 2. What are we going to do with this? We are going to solve it using the quadratic formula, or maybe it's factorable. Let's see. Let's move the 2 over and have 2x squared plus 5x plus 2 equals to 0. we'll have 2x and x. The signs are the same. They're both positive. If we put the 2 here and the 1 here, I think that gives us what we need. B squared minus 4ac should be a perfect square when it's factorable. Yeah, 25 minus 16 is a 3. Okay, great. So either 2x plus 1 is equal to 0 or x plus 2 is equal to 0. Solving for x, we get the two options where we subtract over 1 and get the fact that x is negative a half, and we subtract over 2 and get the fact that x is equal to negative 2. Okay, great. When you're solving a quadratic, you can solve it by factoring. You could solve it by completing the square. Or you could solve it by the quadratic formula. And in this set of 3 videos, the last 2 videos, I solve a quadratic using each type. Okay, thank you.